What is this?
It looks complicated.
How does this work?
I am Faraday! So the law I discovered is that if the magnetic flux changes near a conductor, a current will be induced into it.
Is that right though? No, it's not.
This is indeed a common mistake people make. It is actually an EMF that is induced and the EMF that causes a current to flow.
Grammar.
So how is my law related to the DC generator? Well, if you look from the top of the generator, the coil will look something like this. An external mechanical force will spin it. So then if you look at it from the side, as the coil turns due to the mechanical force, you can see it would intersect the magnetic field. This intersection of the magnetic field is indeed the change of the magnetic flux. Hence, to simplify and summarize in equation form, the EMF produced is equal to negative N times the change of magnetic flux over the change of time. The magnetic flux is B times A, with B being the strength of magnetic field and A being the area of the change, which in the case of a DC generator would be the area of the coil. The N in the equation represents the number of turns in the coil.
Lens.
So what is Lenz's law? Lenz's law states that the direction of induced EMF in the coil will always oppose the change causing it. But what does that mean? Here we have a solenoid. When a magnet is approaching from the right side, like so, the right side of the solenoid becomes the north pole to repel it. Or in other words, oppose the magnet. When the magnet is moving away, how do you oppose that? You oppose that by attracting the magnet back to the solenoid. The right side of the solenoid becomes the south pole to attract it. So, why does this happen? Here, we have conducting loop or coil. When a magnet approaches it, there is an increase in the magnetic flux. So, to counteract this change, induced EMF in the coil flows in a direction at which it will produce a magnetic flux that will go in the opposite direction of the magnetic flux produced by the magnet. So, Lenz's law has an effect on DC generators by producing back EMF. Back EMF is the EMF that acts against the current which induces it. Based on Lenz's law, it opposes the change causing it. Now, we can see from this generator here that when an EMF flows through the coil, back EMF will flow at the opposite direction. Because of this, the total voltage produced will be lesser than it should produce. So, more mechanical energy is needed to produce a desired amount of voltage.
So do you guys understand?
What are you doing?
I've blessed you with physics knowledge. One of you.
So what is a DC generator? A DC generator is an electrical machine which converts mechanical energy into direct current electricity. Okay, I've done what's a DC generator. So some other sources of mechanical energy are a reciprocating of turbine steam engine, water wheel, internal combustion engine, wind turbine, and compressed air. So this is how the mechanical energy comes from. So what is the DC generator made up of? The components which make up the DC generator are the core, which we call the armature, two opposite poles of permanent magnet, split rings, and carbon brush. So this is how the mechanical energy comes from. So this is the permanent magnet, the coil, which we call it as the armature, external circuit, carbon brush, and split ring. The coil acts as the conductor. Its role is to induce EMF. These two opposite poles of permanent magnet is to produce uniform magnetic field. Split rings is to convert AC current to DC current by rotating to conduct to the opposite carbon brush every half turn. Carbon brush is to collect the current induced in the armature, conduct and supply the induced current to the external circuit. As we can see, this red color split ring is connected to this X carbon brush, and the green color split ring is connected to this Y carbon brush. So when the coil rotates 180 degree, green split ring is now connected to X, and red split ring is now connected to Y. Although the direction of induced current in the internal circuit is reversed, but the direction of induced current in the external circuit is still in the same direction. That's all the rule of the DC generator. Okay. When the coil is in its horizontal position, it is parallel to the magnetic field. So the force applied for the rotation of the coil is 90 degrees to the magnetic field. Using Fleming's right-hand rule, the magnetic field is like this, and the force applied is like this. So we can say that the direction of current is this way. Using the same thing, direction of magnetic field, the force applied, and the direction of current is this way. So we can find out the direction of current in the external circuit. So since the theta is 90 degree, so BLV sine 90 is 1. So BLV, this is the x. The same thing, the theta is 90 degree. So So the direction of induced current in the internal circuit is from D to C to B to A. The direction of induced current in the external circuit is from X to Y. So when a coil is in its vertical position, force supply for the rotation of the coil is parallel 0 degree to the magnetic field. Therefore, there is no EMF induced as there is no interaction of the coil to the magnetic field. EMF induced is therefore 0. Torque produced is also 0. Therefore, it shows no deflection. So 0 degree, 90 degree, and 180 degree. So again, the coil is in its horizontal position again. So the force supplied for the rotation of the coil is 90 degrees to the magnetic field. Using Fleming's right-hand rule, the direction of magnetic field, force applied, and the direction of current is this way. Same thing, magnetic field, force, and the direction of current. So therefore, we can find the direction of current in the external circuit. Since the theta is 90 degrees, therefore EMF induced is maximum. (90°), torque produced is also maximum. So the direction of induced current in the internal circuit will be from A to B to C to D. And the direction of current in the external circuit will be from X to Y. So why is it X to Y again? This is because the split rings has swapped their position to the opposite side to contact to the opposite carbon brush. Therefore, the direction of induced current in the external circuit is still the same. And eventually, it produces a direct current. That's what happened to the torque EMF.
As you can see, when only one loop is used, the output of the basic single-loop generator is a fluctuating DC voltage that reaches its peak amplitude and falls to zero twice during each full rotation of the loop. This variation in the output voltage is called ripple and makes the output unsuitable for many uses. This effect can be reduced by using two rotating loops instead of one, positioned at right angles to each other. Each end of both loops is connected to a separate commutator segment, so the commutator has a total of 4 segments. There is an important difference in the two-loop generator. That is, one loop is always 90 degrees of rotation behind the other. So, when the voltage in one loop is decreasing, the voltage in the other is increasing, and vice versa. The position of the brushes is such that as the loops and commutator rotate, the brushes are always in contact with the commutator segments of the loop that has the greatest induced voltage. As the voltage in one loop drops below the voltage in the other loop, the brushes pass from the commutator segments of the loop with the decreasing voltage to the segments of the loop with the increasing voltage. This switching occurs 4 times during each full rotation of the two loops, and because of it, the generator output voltage, which appears between the two brushes, never falls below a value of 0.707 times the peak amplitude of the voltage induced in either loop. This DC output needs less filtering than the single-loop generator. Therefore, it can be concluded that the use of 2 separate loops decreases the fluctuation in the output voltage. It does not, however, have any effect on the peak output voltage. It is only the average output that is higher. By using more and more separate loops, the ripple can be further reduced and the output voltage of the generator made very nearly steady DC.
That's what happens when multiple loop is added to the DC generator.
When the coil is horizontal, the flux is 0. When the coil is rotated 90 degrees, the flux is maximum. When the coil is at 180 degrees, the flux returns to 0. When the coil is at 270 degrees, there is a maximum negative flux. And at 360 degrees, the flux is 0. Now, if we look at the gradient of the graph, at 0 and 360 degrees, there is a positive gradient, and therefore the rate of change of flux is at its maximum. At 90 and 270 degrees, the gradient is 0, and therefore the rate of change of flux is also 0. At 180 degrees, the gradient and the rate of change of flux is at its maximum negative. Since EMF is the negative of the rate of change of flux over the change in time, the graph of EMF over time is a horizontal reflection of the graph of the change of flux over time. So, it can be concluded that EMF is determined by how quickly the flux changes.
Let me explain Fleming left-hand rule and Fleming right-hand rule. So what's the difference between these two hands? One is to find current, another is to find motor. So to find force, you use left hand. So this is child, this is mother, and this is father. So right hand is basically this: father, mother, child. So right hand is to find current. So how you remember like which one is father, which one is mother, and which one is child? So basically, child likes to point middle finger. Mother always points with your index finger, say, "Ah boy, you naughty ah." And father always say, "Hey, good boy, good boy." For this example, to find current, you'll see this thing rotate in this direction, and then there's a magnetic field. So basically you use a right hand, and then yeah, you just follow for N to S for your index finger, and then for your force, you know that this one is turned this way, so you place it down here, and yeah, you got your current. And then another side is basically you don't move your index finger, which is your motor, and you rotate the force upwards, so you'll get a current flowing in another direction. So if you draw this out, it's like this. T equals to 2 NBAI sine theta. T equals to the torque, N equals the number of turns of coils, A equals to area, which is W multiplied by L. You can see this DC generator. I equals to the current, and theta is the angle between the straight line here and the magnetic field line.
So what kind of modifications can we do to the DC generator to make it more efficient?
Increase number of split rings so that when it rotates, it always be in contact with the carbon brush.
The output voltage of a DC generator can be increased by having each rotating loop consist of multiple turns of wire rather than just a single turn.
So we can use smaller but stronger magnetic region to produce stronger magnetic field. For example, neodymium iron boron. Therefore, we don't need a huge permanent magnet, and we can then create a smaller, lighter but more effective DC generator.
Wait, where's Faraday?
My work here is done.